Okay. Now, this is actually called as a roadmap. Okay. Roadmap in terms of um, I can just call it as mm, data analytics. Okay. For um, Azure architecture. Now, the reason why Azure architecture, it is in comparison with OpenStack only. So here it will be in comparison with OpenStack components also. And then along with OpenStack, the prerequisite Python or SQL is mandatory, along with one visualization tool, Talent. Okay. Now, say for example, first we'll discuss about what's like level 1 architecture. Now, level 1 architecture always deals with your primary Azure components, and then your uh, entry level and associate certificates. So I can say entry level and then your associate level certificates. That is up till the point before DP. All this is before, you can say that DP 203, that is of data engineering part. And yes, this also comes under data engineering. Now you guys are also doing since this you guys are also doing this one IBM data engineering certification. Okay, so I'll just write here IBM data engineering certification. Now that also doesn't give 100% clarity, but you will get an 100% clarity here. Just focus that we discuss on data engineering, data analytics on basis of Azure architecture, along with knowing OpenStack, along with prerequisite Python, SQL and Talent. So for level 1, what happens is you always have an data set. Okay, and from this data set you store it to and storage. Okay, that storage might be your either I'll just write here your hard disk, or then your blob if it is Azure. Okay, or it can also be your OpenStack HDFS. Okay, now blob is nothing but that HDFS version of Azure. Azure just calls it blob. So one side you got your hard disk, and other side you got your blob in the cloud, as well as what do you say, you got this thing HDFS, that is big data OpenStack. Now some more options in Azure you'll have is say Azure files. Okay, and then you'll have something called premium storage. Okay, so once we have a data set, we have to store it somewhere. It can be either on your hard disk or your blob or your HDFS. So three things we covered. Now after this is stored, directly next what you do is you take this to either and data warehouse. Okay, I'll put slash, or an analytical tool. So all your premium your entry level and associate certificate will make you use to the cloud Azure, or any other tools or something, even including this can also be as ETL tool. Okay, so it'll always have an data warehouse, or it'll have an uh, analytical tool. Now what are our options of data warehouse or analytical tool? Now when we come to the storage, here also it can also be, okay, we can say here roglial, right? Okay, mysql, mariadb, and either openstack or azure. And then your data warehouse is data factory, or then synapses is azure synapses. And then your analytical tool, when we talk about, okay, we can say like what do you say, one more data warehouse tool can also be as in openstack, uh, talent, or pentaho. This is pi, and then ssis, okay. Now your analytical tool will include something like what do you say, synapses or data factory. Your analytical tool will include first, let us write talent, or then tableau, and then ssis or pentaho, followed by azure components, I can say uh, this one, synapses, and then data factory, and then hd insight. But again, hd insight is big data components, so you don't use that much. You only use synapses or data factory, or this also called as something stream analytics. Okay, all these are maximum drag and drop without coding. Now once an data warehouse and analytical part is done, next one comes is visualization part. Okay, so in visualization part, we can say like okay, and like I told you here, one small thing, database or data warehouse. Database is like your car parking lot that only four can handle. Four cars you can keep, and even if you have Tata Nano, you can keep in your parking lot. Followed by data warehouse is like an stadium parking lot you own, and then you can park only one car, Tata Nano, and nobody will tell you anything. But when that extreme case comes, say you have a function and 1,000 cars are required, then the difference comes where a database or data warehouse what should be done. Okay, now once this is done, your last phase is visualization. Now in visualization is where you extract from data warehouse or your analytical tool. See, in analytical tool you can also visualize, right? You can also visualize, so it's okay. But there are only specific visualization tools, right? For example, your OpenStack will be Tableau or Pentaho, and your Azure stack you got Power BI, the best. Then there's one more thing also on AWS. There's Quick Shift. So everything runs the same. See, under the hood it is same only. For example, even if it is Lamborghini or Ferrari, under the hood it will be some V16 or V12 engines. So same like that, under this hood all are all internal components. Let me tell you, that is Spark. It goes in memory, highly scalable, highly resilient, highly scalable, highly resilient. Resilient means it can have a lot of clusters, or it can small down also when nothing is used. That's why Amazon Big Billion Day also, when normal days it might have some 1,000 clusters, but on big billion day it will gear up for 2000 clusters. Immediately after those 3 days it will downgrade to those again 1000 clusters. So scalability and resilient and in memory. Under the hood everything is Spark components. So that is why once when someone learns Spark or you guys learn Spark from me, I'll have that entire 72 logics, 72 functions, operations, transformations. We will cover like one by one small examples. After that, when you go for a visualization tool, any of the visualization tool like Tableau, Power BI, QuickSight, okay, you'll immediately get to know, hey wait, all this looks very familiar. The reason being all that latest components is Spark that you will get to know. Okay, so this is your level 1 stack. Level 1. So whenever you're going for your entry to associate level, okay, you always have one data set, one storage, one database or data warehouse, and data analytics tool, and then visualization. Now this itself is called as, from here to here, okay, it is called as uh, ETL. Okay, but this entire pipe is called as data pipeline. Now specifically data pipeline level 1. Okay, this is data pipeline, this is data pipeline level 1. So level 1 is more of just drag drop, configure, use, send. Send is send to next service. Okay, so this is all your level 1 of your stack. Now let us go to level 2. The meaning of level 2 is, in level 2 there are actually level 2 1 and level 2 2. Okay, so we can actually call this as level 2, and then here this same thing will be zoomed up for a little bit of coding and in-hand scripts. Now that roadmap or architecture we'll see, and this architecture is also called as data flow architecture. If it is pipeline, it might be a small pipeline or entire pipeline. Data flow, it might be an one service to other service hopping, is called as data flow architecture. Now when we come to level 2, what we'll have is, we'll have some we'll have some collection first. Okay, and then we will have some ingestion, and then we will have some storage. Okay, and then we will have some compute. In compute also there is pre-processing, and then there is processing. Okay, now after compute comes your data warehouse. Okay, and then last comes your visualization or ML AI models, but mainly visualization. So data warehouse and this, and the moment I say data warehouse, understand it will be data warehouse or analytical tool. Okay, so basically in data warehouse also analytical tools are there. Again, analytical tools means data mining tools. So all those, like, just like alias, if I say Big B, everyone will understand who's Big B. It'll be like Amitabh Bachchan, right? But then I'll say like, hey, it should be Big A. No, his name is Amitabh Bachchan is his surname. Then everybody will hit me. They'll tell, "Arey, it is roguely called that. So just go. Everybody likes that Big B, no? So no problem." Like that here only. In computer science world or this architecture world, data warehouse is specific to data warehouse, but then you have to do certain things, right? Manually you do, it is called data warehouse or SQL jobs or PLSQL. But automatically you do by Talent or Tableau, it will be called as some analytics you're doing. So all those are rogue words, but I'm further classifying it very properly. Now I need some help from groups over here. Collection. Okay, understand, in the entire whole wild word, sorry, whole wild world. Okay, so in the whole world you have only two types of collections. One will be file systems. Okay, other will be databases. And then yes, there's a third one, hybrid, that is called as data migration services. Data migration service. Okay, now for this the time is 1, so group 1, are you there? Yeah, what kind of files have you used in your either engineering time or your job time or anything? What kind of files did you use?
Hello, Shiva. Hello.
Yeah.
Yeah, actually, I have used
Hmm.
Excel file,
Hmm.
CSV,
Hmm.
and TXT file,
Hmm.
Note, Notepad. Then
Hmm.
now in our new project, one API also coming
Hmm.
that we are trying to implement.
Hmm. Okay. So can I say all those are system files only what you told?
Yes, yes, yes. JSON file also I have used.
JSON
JSON.
also comes under system file only, right?
Yes, yes, yes,
So if any files you use, that will come under either system files or databases, meaning that if it's your
yes,
Microsoft Windows you are using, your hard disk is NTFS.
yes, yes,
If it is Linux, it is called as extend2, and if it is Mac, it is called as DMG. So your hard disk that is raw data is converted to either NTFS, extend2 or DMG. Then after that is where you have either text file or CSV file or JSON or TSV, tab separated value, or Excel.
yes.
Okay,
So all
or
this file we are
log
loading to
files.
database.
Yes,
Yes,
or log, not only database, either storage or database, right?
okay, okay.
Yeah,
Yes, yes,
so log files, and then you have even some avro serialization deserialization files. You got some park rate files. Okay,
yes,
all those are these files, but everything comes under the category called file systems. Or if it is a database, the second type, it will be an SQL file or a NoSQL file. That's it. So in the whole wild world, you have your only collections under file systems or database. Now this migration is from one to a source to a destination. That source and destination can be this permutation combination of the file systems and database, either in one place only or in different place. So that is why this data migration services comes under collection, meaning that you can move from a file system of one to a database, or database to any of the file systems in that same computer, or it can be a different computer. It is just a permutation combination, and that comes under data migration services. Okay, and that is your
yes.
collection. Now once you are done with your collection, the next is ingestion. Can anyone tell me the most common ingestion everyone must have used, but you don't know that it comes under this category? Like I told you, the moment you know this, you guys, you possess at least 3 years to 5 years experience. That much of knowledge I'm pouring into your mind. Because if anybody client, any project manager, anybody opposite of you test your knowledge, and you prepare at least on this roadmap the knowledge that you have and you possess, they will think this dude is a fresher. No chance, no way. He's got too much of knowledge. I think he's got real experience. He's just hiding. I think he's just being modest. Damn sure he's not like a fresher. He's got some secret knowledge. So your talk will be like that. Okay. So one common ingestion that everybody uses, but you don't know that it comes under ingestion is upload. That's it. Upload your dataset. The moment you choose your dataset, or upload or read dataset. The moment you upload your dataset or read your dataset, that is the most common type of ingestion that everybody use. Then the second one type of ingestion you guys use is source redirect. That is, meaning of source redirect is, you might be in one service, your storage might be in blog or somewhere. Okay, you will just redirect its URLs. Okay, or in your Jupyter notebook or somewhere also you might have redirected some data set that is there in some website. So this is just source redirect, or just giving path giving from internal or external, internal or external. Okay, so this is the second type of ingestion. And the third most common type of ingestion is extraction from DB. Extraction from DB, that is your SQL or your NoSQL. Okay, and then your fourth is your API calls. Okay, APIs, that is, the meaning of APIs is it is third party, and that's a whole different story about API. Don't think API is only one. API itself means that application processing interface. It can be a live streaming, it can be asking your credentials and then you sending it and then it sends you a request, or it can be a common other type, like just you give access and every hourly it'll dump like your RSS feeds. So API has a quite a lot of subcategories, but just understand it's a third party ingestion. Okay, now after this is again your components. Components meaning that your data migration service is also an ingestion. The reason being, it is doing from a source to a destination, and the destination part can be your ingestion. Okay, if it's a source to a destination, you might be here, so for you it is an ingestion. You understand, right? It is at the receiving end, so that can be an ingestion. And the second type will be static ingestion, like just your upload, source, extraction and all. And third one can be your in streaming process. In streaming process. Okay, now in streaming process, it can be Azure Kafka, Azure Kafka. Okay, or it can also be like an newer version is there, that few other versions are there, like in streaming analytics or something. Or wait, let me actually, that component name I always forget. Um, compute, mm, inside this catch. So basically it's stream analytics. Yeah. I There's another one also. I just forgot. If I remember, then Kafka, Azure, Stream Analytics. Okay. So these are the ingestion ones. Okay. Now after ingestion is done, okay, you have to store it somewhere, right? Like where do you store it, right? I mean, you have to store it somewhere, right? So the first type would be of file systems. If it is from file systems, right? I'll just write here. If it is from file systems, it'll be your Azure Blob, or then it might be your Azure Files, or then premium storage is also there, or third one might also be your HDFS, that is you have your HD inside, that is Hadoop's storage, or it might just be your local only. Now this fourth one is just your local, in the sense you're not doing in the cloud, it is local. Okay, but then again these are all file systems. And then your fifth one you got Azure MySQL or Maria, and then you got Cosmos DB. So all this is like SQL, and then this is NoSQL. Okay, and you got even what do you say, that lake, data lake, what is that called, uh, data lake warehouse, lake, no, shared DBs are there, shared databases, then synapses, or okay, uh, let's just keep it short. Your data warehouse is there, Azure MySQL data warehouse. Okay, and then your eighth is Azure's data lakes, so that is even more bigger than uh, data warehouse. Okay, so storage, these are all the things. Okay, and also like see, not only this storage, but in your analytical tools, okay, in your analytical tools like Synapse ADF, Data Factory, and Synapses, also some internal storage will be there. Those are all small storage. Okay, so you don't have to like worry about that. Next comes, once you got, see, once you got your collection, your ingestion and storage, you have to compute something, right? Now in this compute part, okay, there's again, like I told, in level 2 there's level 1, and then there's level 2. Level 1 is all your big data components, big data stack. Okay, that is, it'll consist of all your big data stack, that is HD inside, that will have all the versions of Hadoop, and then wait, I'll just draw here, Hadoop, Hive, HBase, Pig, Scoop, Flume, Avro, Zookeeper, Ambari, so a lot more. uh, Machine learnings, manhout, and all it has. So this is actually an OS, big data OS for Azure. Okay, and any stack related to this component is level 1, level 2 is level 1, that is big data stack. And the only thing over here is distributed compute and then storage, that is only distributed compute and storage in the form of master and slaves or data nodes and all. It's like joint forces, right, like transformer robot. But then again there's also something called as level 2 stack. Now level 2 stack is of Spark components, that is Spark itself is like a second version of Hadoop, that is big data. Okay, so this is level 2 Spark stack, meaning that it has distributed computing and storage, but also in memory processing. So it is, that's why 50 times to 100 times faster than data stack, but it is also a little expensive than big data stack. Now when Spark components are all your synapses, data azure factory, your data lakes, all the latest components are built under the Spark engine, okay, in memory processing. Now here where like your ADF, your synapses, and then your stream analytics, your ML and all is there in level 2 stack. So level 1 and level 2. And don't consider Spark is something else. Inside Spark itself, Hadoop is there, or this big data stack is one. It is built on top of that. It's like how you can say, um, mm, like Royal Enfields, the older versions, and Royal Enfields newer versions. Newer versions are more nice, right? More faster or something like that. Spark is way faster. It's like 50 to 100 times, and it is more in sync to your data science or everything. Now you remember I wrote here pre-processing and then processing, but this is just level 1 and level 2 stack that you are aware. Now after this is what we come to pre-processing and everything. When it comes to compute, okay, I'll just write this here. This third third in the section of compute section, you always have first importing your modules, and then 2, you always have importing data set, okay, and then 3, you all okay so far, okay, 3, you got pre-processing, and in pre-processing itself there is first missing values, and then your what do you say, noise, etc. And then your second one is like feature engineering. Now feature engineering is where you got like what do you say, normalization, standardization, okay, and then what do you say, your outliers, and then your distribution, one hot encoding, one hot, that is to categorical variable, all a lot of different steps in feature engineering, followed by next one is feature selection. So feature selection is your column reduction or dimensionality reduction, okay. And then after pre-processing is done is where your processing takes place. That is, in your processing is your what you can say, in your processing is your filters, transformations, and your logics, your Python logic and all those things, okay. Once this 4 is done, okay, your fifth step is visualization, and then your sixth step is ML prediction, ML model. If you want to extend, use all your algorithms for linear regression, polynomial regression, multiple regressions, decision trees, random forest, SVM, XGBoost, ensemble learning, and all for different use cases for different things, either classification or clustering. Different algorithms you can use, or your recommender systems like ALS, ALP, and all those recommended logics you can use, or your neural networks you can go. So this one opens an entire field on your next one, and this ML modeling is only your level 3, okay. And then seventh one you got as AI models. AI model is your level 4. In AI model also uh, Queen Sims algorithms, and then LSTM models, and then self-learning NLP chat models, all those, or a little bit of complicated like vision AI, your CNN side, your self-driving cars, all comes under level 4 AI models. So after visualizations is enough. After that is more advanced. So if you see this compute part, let me just stop till here, followed by your data warehouse. Once this compute part is done, that inside tables you get in the step 5 visualization, okay, that inside tables or lot of new columns and tables that you get has to be stored somewhere. So that is where this, what you say, data warehouse or analytical tools again, um, one like your a azure uh, data warehouse, or then your two, your azure data lakes, okay, along with in coordination with synapses, okay, is used for your storage and then retrieval analytical process of those files that have generated from this compute section, okay. So your data warehouse and analytical tool is that. Now once it is there in your repository and your data warehouse, say after 1 month also the client comes back or a new client of similar person comes, your project manager can directly retrieve from the data warehouse and visualize by Power BI or Talent, or tree is Tableau. And I forgot to mention Informatica before. In all this talent things and all, Pento Informatica is also same. I'm just writing top. So this forms your visualization. Now this visualization is formed, and this is level 1, right? This entire thing is level 1, and this is entire till visualization is level 2. Now can we say, or did you see, level 1 is actually level 2 minus this compute part. In level 1, that is your entry and associate certificates, it will have a data set, storage, data warehouse or DB, analytical tools and visualization. In level 2 also you got collection, ingestion, storage and data warehouse, analytical tools and visualizations. So that is your level 1. But level 2 requires you a knowledge about big data components, that is level 1, or Spark components, that is level 2. And in level 2 only machine learning is also there. But after level 2, more advanced is machine learning models, that is level 3. Even more advanced is AI models, that is level 4. But your level 1 and level 2 in computation, you have to know about big data stack, Hadoop, Hive, HBase, Pig, Scoop, Flume, Avro, Zookeeper. Everything component is there in HD inside. That is just the big data OS. Or the second one, level 2, that is Spark, that is in memory processing. And only difference between big data and Spark is, in big data is just distributed processing, compute and storage is distributed. But in here it is RAM, in memory processing. Not only RAM is distributed storage, but in memory processing in the RAM. So that's why it's 50% to 100%, 50 times to 100 times faster than Hadoop. That logic I'll tell you when we go near Spark. But over here Spark components, all your ADF, synapses, stream analytics, your Azure ML, all these are built on internal components of Spark only. And then when we come to compute section, what is the flow of a compute? It'll always start with importing your modules, importing your data sets, and then doing a pre-processing. And this pre-processing is also like missing values, noise, normalization, noise. And feature engineering is like your normalization, standardization, outliers, distribution, one hot encoding and all. And your feature selection is about your dimensionality reduction and then correction or trying to do. And then comes your visualizations part, and after your visualization, all the important tables, columns, transformations and all that you did after this processing, right, filters, transformation, logic, you save it under after your visualization in your data warehouse. So that step is over. That is where you project your client. Then client might request, okay, we need some ML models also, you can go, or up till here analytics is more than enough, we don't want ML. Why? ML model also, again, it's for prediction. There are also two types of prediction, from past to present or from present to future. You want to do from past to present is your predictive analytics, but from your present to future is your forecasting machine learning. Okay, and then your fourth one is your AI model. So this is under compute that you have to master, and this is where your data engineering and 2p DP203 also covers little bit only, but this is the full stack. And if you see this compute part here, this is actually your data science part. And the only difference between data science and this Spark compute that we do is, if you only want to do in your laptop, you need to know pandas and Python and Jupyter Notebook Anaconda. Fine. But if the client says हम तुम्हारा लैपटॉप क्लाउड में चलाएगा क्या, और एक सिस्टम में चलाएगा क्या, बिग डेटा टेक्नोलॉजी कब है, so because of that, whatever codes are there in your data science same codes in Python and Anaconda, those will be just changed to PySpark codes. And PySpark is not much different from Python, but a little difference will be there in calling the modules and also trying to know it. It will be more like SQL like fused with Python. So that is why while using Spark, both an extreme experienced developer of Python also comfortable in PySpark, and person who has done, who's not a coder, who's a DBA, he is also a database administrator, 10 years experience, he will also be comfortable in Spark, PySpark. That is Spark and PySpark differences. Spark is the component, the language. When you use Python to do it, it's called as PySpark. And this is the data science phase of that. And the actual entire phase I've told you, and under classifications, very premium content, this one not available in internet also, pure experience. Okay, and followed by data warehouse on your analytical in Azure. In this case, if you guys would have been in AWS or GCP, I would have told different components, but since Azure data warehousing, Azure data lakes, synapses and all, and then visualization ML models, Power BI, Talent and Tableau. So level 1, just before you reach DP203, all this stuff is there. But in level 2, more than little DP203 as a reference, this is there. Okay, and for your batch specifically, since all this level 2 is there, along with you guys are doing this IBM data certification, now you understand this IBM data certification is making you prepared for Python, SQL, and then this data science compute part. But now you understood where your IBM also fitted. But IBM doesn't teach from starting to finish. Why? They are experienced. But I've learned all this. Why? I've done my engineering, I've done my MTech, I've done my MS, I've done my PhD, and I've been the lead data scientist. And then lot of projects, 172 projects, sorry, 117 projects, and still counting. And that experience made me gain that, hey, wait, why will I put this in complicated way? Let me put it in one slide so that one can understand the entire architecture and the entire roadmap. So now you see over here the difference between YouTube videos and what Cloud that our trainers and me and all we do. Ultra premium content, your lifeline for next 10 years guaranteed. And anybody hears you explaining in this way also, their eyes will open. They might come and cry, sir, you have opened my eyes. I was facing very confusion, I was facing what not, why am I learning this, where it is integrating also I don't know, but before entering into projects only now I know everything. That is what you're supposed to know. Okay.